Hello students, welcome to the third lecture on ground improvement techniques. In the previous class, we have completed first technique, that is vibro flotation, which is divided into two types, vibro compaction and vibro replacement. So that one is completed in our last class. In today's class, we are going to discuss about dynamic compaction, the second method to densify the granular soils. Okay, dynamic compaction means dropping a heavy weight from certain height. Okay, due to the dropping of heavy weight, they are going to generate some stress waves or vibration waves that are penetrated through the soil, which helps to compact the soil. Okay, so let's see. The first point is the dynamic compaction involves. Okay, first one, the process involves dropping heavy weight repeatedly on a ground at regularly spaced intervals. Okay, this is important point. For example, we have a rectangular shaped area, then we need to drop the weight at regularly spaced intervals. Okay. Second one is the main two factors that decide the amount of compaction are weight of the tamper and height of the drop. Okay. These two factors are the important ones to determine the amount of compaction. If the weight and height are more, then the amount of compaction will be more. Or if the weight and height are less, then the amount of compaction that could occur is less. Okay. So these two are the main factors that determine the amount of compaction. So the next one is dynamic compaction is applicable for wide range of soils. It is applicable for almost all type of soils, which include loose sands, okay, silt or dune sands. Dune sands means the sands that are occur due to the dunes that are actually occurs in Rajasthan. Okay. Next one is inorganic fields. Inorganic means inorganic, which does not contain any organic matter. Landfill means man-made fields. We are going to fill the waste material onto a land. Okay. Such type of lands are also compacted using dynamic compaction method. So let's watch a short video. So for example, we have a site that we need to compact it. See, for example, this is our site that need to be compacted. So what we have to do, the first step is we need to divide the entire area into some spots like this. Okay, this is our entire area. We need to do marking. The first marking is given by square shapes. Okay, these blue shapes we need to compact first. Okay, so let's see. First we carry out compaction only on these markings. Okay. See. When the weight is dropped, they are going to penetrate a stress wave into the soil. Okay. The total area is this. Due to one place when we compact, this much of area is getting compacted. When we move to the other side, again this much of space is going to compacted. Okay, the shape is trapezoidal. See, when the weight is dropped, this much of area, this trapezoidal area is going to compact due to the stress wave developed. Okay, when the load is dropped, immediately a stress wave is going to penetrate through the soil. Okay, again move to the second mark. Okay, we already completed the marking. Move to the second mark. Likewise, we need to do all the markings compacted. See, all the square marks are compacted. Next one, give marking between these places using circular marking. Okay. Before that, we need to fill all these indentations. Okay, and just lightly compacting. Then do the marking using circular ones. Okay. First of all, we completed the marking compaction of square areas. Now we are giving a circular areas in between the square areas. Again, do compaction work. See here. Due to the first compaction, this area is compacted, this trapezoidal area. Then we move to the next position. This trapezoidal area is compacted. Then move to the next position. So likewise, we need to compact the entire soil. Okay. So watch the video. So this is the mechanism. Okay. So we now completed the circular shape compaction also. First of all, we do compaction on these one areas, sphere areas. Then on the circular areas. Again, we are filling the soil on compaction with the rollers. That too to compact only this layer, top layer only. Okay. So this is the dynamic compaction method. Okay. Again, this time we are compacting the cross mark areas. Okay. Likewise, we need to carry out compaction in 3 phases. Okay. In the first phase, we do compaction in sphere areas that are marked with blue color. Then we compact the circular positions. Okay. Then we compacted cross mark positions. We totally compacted the soil in 3 times. Okay. So coming to the specifications. In your exam point of view, this is the most important question. What are the specifications for dynamic compaction? So let's see. The first one is weight of the tamper. These are all are approximate values. Okay. Generally the weight of tamper is 8 to 30 tons. Okay. Coming to the height of drop. The height from which the weight of the tamper is going to drop. That is generally 2 to 25 meters. Okay. The next one is capacity of crane. Whether it is a crawler crane or a tower crane. So the capacity of the crane should be more than weight of the tamper. So in order to lift 8 to 30 tons tamper, we need a capacity of crane of 50 to 100 tons. Okay, this is the capacity of crane to lift the weight of the tamper. Okay, see, this is the important point. The height of the drop and number of compactions. Repeatedly we are dropping the weight, right? So what are the number of compactions are varied from soil condition. Okay, from soil to soil, the height of drop, the weight of the tamper and number of compactions are going to vary. We cannot fix those values. But these are all approximate values only. Okay. Coming to the principle. Principle means working mechanism. The mechanism is very simple. As we drop weight tamper from certain height, it is going to create some stress waves. Okay. It develops some stress waves that helps to densify the soil. Okay. Those stress waves are penetrated into the soil. Those are going to densify the soil. Okay. However, the principle is different in cohesionless soils and cohesive soils. Okay. In cohesionless soils, the densification is occurred using some principle. In case of cohesive soils, the principle is different. Okay. For example, in cohesionless soils, so what is happening? The waves create liquefaction. Liquefaction means, we already discussed. Liquefaction means it is a phenomena of losing shear strength. Shear strength means resistance to shear stresses. Liquefaction means it is a phenomenon of losing shear strength and stiffness of soil. Stiffness means resistance to deformation. Okay. Once liquefaction occurs, these two values are 0. Stiffness means resistance to deformation. If we apply certain load on the soil, it will not deform very easily. It offers some resistance. That is known as stiffness. Okay. So let's see the principle. These waves create liquefaction. Liquefaction means 0 shear stress and 0 stiffness. So as there is no resistance to deformation, the soil easily compacted. Okay. Then followed by the compaction. Once liquefaction occurs, it loses its resistance to deformation. That is stiffness. So when there is no resistance, the soil can be easily compacted. Okay. That is the phenomena in cohesionless soils. Whereas in case of cohesive soils, the waves increase the amount of pore water pressure. What is pore water pressure? So let's see, this is some soil. Natural soil contains water. We know that natural soil is a 3-phase system. It contains of solid particles, air voids and water voids. So there should be a presence of water voids. Right? When we apply the load on the soil, obviously the solid particle settles down and the water between the solid particles tries to move in upward direction. Okay, when we apply the load, obviously all the water from the soil tries to move on upward direction. That is known as pore water pressure. So what it is doing? It increases the pore water pressure. that is more amount of water is coming out of the soil. So as more amount of water removed from the soil, it gets settled. Okay. So this is the phenomena in cohesive soils. In cohesionless soils, it creates liquefaction. Simply, it loses its stiffness. Okay. It is very free to deform. That is what is meant by liquefaction is. So once there is no resistance to deformation, it is easily be compacted. That is in cohesionless soils. Whereas in cohesive soils, more amount of pore water is coming out of the soil. So once the water is removed, the soil gets settled. Okay, nothing but compacted. So this is the principle of dynamic compaction. So let's see. For example, W is the weight of the tamper. Let's imagine this W is the weight of the tamper that we are using to compact the soil, where H is the drop height. So from which height we are going to drop the tamper. Next one is D is the maximum depth. So by using this weight and this height, up to what depth we can compact the soil? So that is the question. Obviously we need to find the depth of the compaction, right? Then only we fix the weight and height. For example, we need to do compaction for a depth of 20 meters. We need to compact the soil up to a depth of 20 meters. So what is the weight of the hammer and what is the height of drop height that we need to fix? Okay. So let's find. This is the formula to find the depth of the compaction, where D is the depth of the compaction is equals to N into root MH. M means mass of the tamper, H means height of the fall in meters. So what is this N? N is a constant. N is a constant that vary from soil to soil. For example, for sands, the value is 0.5 to 1. For clays or seals, the value of N is 0.3 to 0.5. It's an empirical constant value, changes from soil to soil. So by using this formula, we can find out up to what depth we are going to compact the soil. Okay. This is also an important question regarding examinations. So the next one is compaction energy. The depth of the compaction is required to find up to what depth we are going to compact. Whereas compaction energy is required to find whether the soil structure is going to break or not. If more compaction energy is generated, then the soil becomes a powder form. Okay, we need to prevent that. We just need to compact the soil. We don't need to break the structure of the soil, right? So compaction energy is also very required. So the formula to find compaction energy for each blow is equals to mgh. M means again mass of the tamper, G means gravitational constant, H means height of fall in meters. So by using this formula, we can find the compaction energy. Okay. Next one. The spacing between the impacts should be depend on various parameters. We can fix the spacing for each compaction. Okay. So these are the 4 points that depends that affect the spacing of impacts. The first one is depth of the compressible layer. If we need to compact more depth of layer, which means a lot of depth we need to compact, then the spacing of layer should be more. Okay. If we need to compact more depth, we need to maintain more spacing. If we need to compact less depth, we need to maintain very closely spaced intervals. Okay. So that is the first point. Next one is permeability of the soil. If the permeability of soil is very low, then we could place some close intervals. If the permeability of the soil is very high, then we can increase the spacing between the intervals. Okay. The next one is location of groundwater level. If the groundwater is available at very low height, for example, this is the ground level, this is the water table. If this height is very less, we need to space very closed intervals. Very closely we need to drop the height. If the water table is available at larger depths, then we can increase the spacing between the intervals. Okay. The next one is deeper layers are compacted at wider grid. Wider grid means the spacing is more. Spacing. Upper layers are compacted with closer grid spacing. Closer grid means the spacing between the intervals is very less. Okay, so these four are the major factors that affect the spacing of intervals. Okay, see, this is the spacing. First of all, we drop the weight at this location. Then we move to this location. So what is the spacing between these 2 points is the question. Okay, that is depending on these 4 points only. Based on these 4 points, we fix the spacing between two impacting points. Okay. So up to now we have completed dynamic compaction, the second method to densify the soil. The third and the last method to densify granular soils is stone columns. Okay, this is very similar to the vibro replacement technique. In vibro replacement, we are adding new soil, whereas here we add some granular materials, that is chips. Okay, so let's see. Stone column, it involves adding of vertical columns of stones. Okay, this is the only difference between vibro replacement and stone columns. In vibro replacement we use new soil, but here we are using stones as a new material. Okay, to compact the ground at least 4 meters below the ground surface. So at least 4 meters we need to lay these stone columns. Okay, so coming to the next one, stone columns helps the stone columns will reduce the chances for liquefaction. Okay, so let's see how it is going to reduce the effect of liquefaction. The first one is densifying the soil through vibrations. In the vibro replacement and in stone columns, the principle is same. We are going to penetrate the probe to required depth and impart some horizontal vibrations. So once we impart the horizontal vibrations, it loses its stiffness and shear strength. As a result, the soil settles down. Okay, even in the future, if earthquake occur, then again the vibration forces will develop, but those will not affect the soil. Why? The soil already loses its stiffness and settle down. So the future vibrations cannot create the liquefaction. Okay. The second one is we are reinforcing the soil. The soil is not a homogeneous material. We are adding some stone columns at regular intervals. Okay, that prevent the liquefaction. So stone columns are laid using two methods. The first one is top feed system, second one is bottom feed system. By using these two systems, we can lay the stone columns. So let's see the first one, top feed system. So using top feed system, how we are going to lay the stone columns. See, vibroflow at top feed. Top feed. Feed means giving. Okay. So let's see the first. See, just as in the case of vibro replacement also, the probe contains water jets, right? The water jets creates a quicksand condition at the bottom. That means the soil is in a slurry form. With the self weight of the probe, it penetrates to the required depth. We are not using any hydraulic or impacts to penetrate the probe. Just because of the self weight, the probe is penetrating. Okay. After we penetrate it to required depth. So this is a simple mechanism. See, there is a space between vibrofloat and soil. Okay. There is a clear space between the probe and soil. From that spacing only we are laying the stones. See, observe closely. There is some space between the probe and ground surface. Okay. So after we compact it to required, after we penetrate it to required depth, we are adding the stones from the top. Okay, that's why it is known as top feed system. We are feeding the stones from top. So once it reaches to the bottom, again the probe is penetrate into the stones and create vibrations, so that the stones will get compacted. Okay. Again it is going to lift for certain distance. Again we are laying the stones. Likewise we complete the stone column. Okay, this is top feed system. We are laying the stones from top. See, this is it. Again move to the second position and do the same exercise. Okay, see, the probe is penetrated into the stones also. Why? To create vibration forces, so that the stones are also gets compacted. So when it comes to the top, okay, this is what is why top feed system is. So let's see, if they ask in examination, you need to draw these diagrams. The first stage is penetration. So in first stage, by using the water jets, the probe is penetrated to required depth. In the second stage, we are going to feed the stones. Okay. On the third stage, we are going to compact the stones. We are not just leaving it by feeding the stones. We are also compacting the stones. Then finishing work. After we completed, we need to do compaction using a roller. Just to compact the surface layers. So okay, this is what is top feed system. The second one is bottom feed system. In this method, we feed the stones from bottom itself. We are not laying from the top. See, in this case, we do not require any jets. In the first one, we need jet. Why? To remove the soil in this location, then we need jet. But here, it is a dry top system. Okay. After we penetrate to required depth, see the arrangement. A pipe is already connected to the probe. From the top, the stones reaches to the bottom. There is no space between the probe and surface. Okay. In the previous one, there is a clear space between the probe and ground surface. From that, in that space, we are laying the stones. But here, there is no water jet. Okay, we are just penetrating using vibration, horizontal vibrations. See, this is the bottom feed system. See how the stones are reaching to bottom. We are going to lay the stones on up. Through the pipe, the stones are feeding to the bottom. Okay. So this is a bottom feed system. Again move to the second position and lay another stone column. Again move to the other position and lay the stone columns. See, again move to the other position and lay another stone column. See, like this we need to lay number of stone columns. So once all are completed, we can do the construction work. Right, this is a highway work. So we laid an embankment through which the vehicles need to move. So this is bottom feed system. Okay, the process is very similar. Penetration, stone feeding, compaction and finishing. The only difference is in the top feed system, we are feeding the stones from top. But here, we are feeding the systems from bottom itself. Okay, that is the only difference. See, this is a practical image. This is a probe and a pipe is connected to, and the area is enlarged so as easy pouring of stones. See, this is another method. By using two stones, we can pour the stones. Okay. Coming to the suitability. Stone columns are best suitable for sandy soils only. Why? We cannot create the vibration forces in case of clay or silt. By using vibrations, the best soil to compact is sandy soils. So the stone columns are suitable only for sandy soil. For example, even if you have a silty soil, even if you have silty soil, what we need? We need greater concentration of stone columns. We need to lay more number of stones. Okay. Next one is because of the large equipment required. We need so much of equipment, right? See here, the probe, the crane, and another pipe. So as we need so much of equipment, this method is not suitable for small construction work. Okay. Coming to the functions and uses. To increase the bearing capacity, it has so many functions. By using this, we can increase the bearing capacity of the soil, and we can also improve the stiffness of subsoil to decrease the settlements. Stiffness means resistance to deformation. Okay, what we are improving the stiffness. That means we are improving the resistance to deformation. The third one is to carry heavier loads. Okay, if we lay the stone columns, those can carry heavier loads. More economical than piling. If we lay the piling, the cost of piling is more. But here we are just leaving the stones. So that's why it is less economical. And next one is, we don't need any waiting period after installation. Once we lay the stone column, immediately we can move to the other position and lay another stone column. So there is no delay time. Third one is homogenize variable soil properties, which means it improves the properties of homogenizing means making the soil properties as constant. Okay, so these are the functions and uses of stone columns. So in our next class, we are going to discuss in situ densification of cohesive soils. Okay, let's summarize today's class. Summary. So what we have learned today? The first one is, we have learned the second method of in situ densification of granular soils, that is dynamic compaction. What is dynamic compaction and what is its principle? So what is the principle? The principle is different in cohesion-less soils and cohesive soils. In case of cohesion-less soils, dynamic compaction creates liquefaction condition. As a result, the soil gets settled. Whereas in case of cohesive soils, the vibrations increase the pore water pressure. Okay, once all the water coming out of the soil can settle very easily. The next one is, what is the depth of compaction? This is a formula to find the depth of compaction. By using the weight of the damper and the height of the fall, we can find the depth of the compaction. Next one is compaction energy. What is the compaction energy that is created per each blow that we calculated? The next one is stone columns and the spacing, that is not important. The next one is third method to compact the granular soil, stone columns. It has two types. What is it? Top feed and bottom feed. In top feed system, the stones are laying from the top, whereas in bottom system there is a pipe arrangement to feed the stones at the bottom itself. So finally, we learn what is the suitability, functions and uses, okay, of the stone column system. In what cases stone column is suitable and what are the functions and uses. So in our next class, we are going to discuss about in situ densification of cohesive soils. Thank you.